Okay, day 4, part 2. We left and we were looking at movies and gender to see if there's a relationship between gender and the type of movie you like. And I think we could all guess and say, maybe. I know there are girls that like the same stuff as guys and vice versa, but a lot of women prefer The Notebook or really like that movie. I couldn't stand it. I couldn't bring myself to watch it. But I know that if you ask the people that liked it, you'd probably get more women liking it than men. But we're saying, what would we expect to get if we surveyed 220 people and there was no relationship? We would expect, okay, in a population just like the one we surveyed, 30 men to like Mr. and Mrs. Smith, 49 to like 300, and 41 to like The Notebook. And again, that would be out of a population of 120 men, 220 total. And so we would take these values. Okay, this is what we got, but this would be what we actually would have expected to get. So we're going to now compare, just like standard deviation and everything else, the difference. So we go ahead and take these values and we're going to put them in a table. So we got these three here. They go right here. Okay, and this is what we observed. Oh, excuse me, I lied. These three here go here. This is what we would expect to get. These came from our observed table back here. Okay. So here's our chart. It is men and Mr. and Mrs. Smith, men and 300, men in The Notebook, similarly female, female, female of the same movies. This is what we observed in our survey. This is what we expect if there was no relationship. And we want to look and see how big the difference is. Because remember, with the flipping the coin example, if you got 60 heads and 40 tails, but you expected 50 heads, 60 take away the 50, that's just a difference of 10 coins off, and that's not that big of a difference for us to say that I was cheating or that there was a fake coin. Okay, so we take the observed value minus the expected value, so 25 minus 30 is -5, and then just like with standard deviation, we square it because otherwise they might add to 0. Okay, and we get -5 squared is 25, and we're going to do that with every value. So 80 minus 49 is 31, squared is 961, etc. So go ahead and write that down, pause it if you need to. Okay, so very similar to standard deviation. And then again, we are now going to divide by what we expected to get because we want a probability of getting this. Okay, so this was the frequency of expected. So for this one, we had a difference of 25, but we expected to get 30. So that's 0.83. And if you're able to do this by hand for your IA, you go out as many decimal places as possible. And we would do that for all of them. Okay, and then we would add them up. And this is our chi-squared calculate value right here. This is the value we've been doing this for. 81. This is the measure. Let's see. 81.253. Or I guess once you're done, we've got to think sig fig, so 81.2. This is the measure of how off from what we expected. And frankly, that's pretty big. Okay? We need to know what we want it to be small if we are going to accept our null hypothesis that there's no relationship. So let's look at that again. 81.253 is a measure of how off our observations are from what we expected if this was independent. Okay, gender and movie choice was independent. And 81 is pretty big. But we need a cutoff of how big is too big or how small is small enough. Just like if we flip the coins. Okay, 60-40, that seemed an okay difference, but 97-3, that seemed like too big of a difference. Okay, we need to know a cutoff. So here's how we do that. And we'll talk about this part later. Okay, and what we need for that is the degrees of freedom. Degrees of freedom is the number of rows by the number of columns. And in our thing, we had males and females. Those were our roles in our original table. So that is 2 minus 1, and we had 3 movies, so that was columns. So 3 minus 1, which is 1 times 2, or 2, so we have 2 degrees of freedom. And what it does is this just helps us pick out the cutoff value. Okay, so right here, number of movies minus 1 times number of genders. Okay, we have 2 degrees of freedom for this example. And that went that way and this way, actually. Okay, here's a rule of thumb and explanation for that just quickly. Consider placing the numbers of 5, 6, and 8 into this table. For the first position, we could have any 3 numbers, right? 5, 6, and 8. We have freedom to choose. But the minute we pick one, okay, we only have 2 remaining numbers. So let's say I decided to put the 6 right there. Now we only have 2 numbers to choose. I decided to put the 5 right here. Now there's no choice left, okay? So there's no choice. So I started out with 3 numbers, but if I'm going to choose where to put them, I really only get to choose where to put 2 of the numbers. The last one is forced to go there, okay? And so that's where we get our degrees of freedom formula, and it explains it more here. I'll let you read that by yourself. But why do we care? Because it helps us find our cutoff value. So the chi-square distribution graph looks something like this. It's kind of this looks kind of normal. It's not, depending on the number of degrees of freedom. Okay, it gets a little weirder looking. But the average cutoff values are 10%, 5%, and 1%. And these are called significance levels. Okay, and they're the ones most commonly used. Okay. The chi-squared values exist for up to 100 degrees of freedom, and for other significant levels, those then given alongside. Notice the 5% significance level with a degree of freedom of 1 has a chi-squared value of 3.84. So let me show you what I mean. They're telling you how to read the table here. If you had a 5% significance level, and this is the one that we will always use unless told otherwise, and 1 degree of freedom, this is how they would write that. They'd say your chi-squared significance value, or your critical value, at 5%, okay, at 5% is 3.84. We had 2 degrees of freedom, and we want to do the 5%, so our cutoff is 5.99. What does that mean? It means anything smaller than this value is small enough to be by chance. Anything bigger, there's something going on. So I'm going to read this to you. Okay, well, let me just explain. So this is the cutoff, and we call this I'm going to go back up here. We used our table, and we found a chi-square critical value at 5%. Was 5.99. Okay, if the chi-squared crit is less than the chi-square calc value, we can reject the null hypothesis. If the chi-square crit, let me pause for just 1 second. I paused for just a second because although that's true, we usually write it the other way. So I am going to rewrite this for you. The same thing, just writing it with the critical value first, or with our calculated value first. If our chi-squared calculate value is less than our chi-square critical value, then we can fail to reject the null hypothesis. If the chi-squared calculated value is greater than the chi-square critical value, we can reject. And we'll have to talk about this in class, but in this case, let's see what we have. Our calculated value was 81.2. Our critical value was 5.99. Okay, so our calculated value was bigger than our critical value. So we're going to reject the null hypothesis. Let's go all the way back up here. Our null hypothesis said the movie choice and gender are independent. we're going to reject that idea. Okay, that they're independent. I believe that there may be some type of relationship or association between the two, i.e. maybe men like action movies more or something like that. But all we're able to do is reject the fact that they're independent. We see some relationship going on there, but we don't know what it is. Now, this is an old way to do it. A better way and a way with your calculator would be to use just probabilities or p-values, and we will talk about that in class.